MC Fifth Sem B section. So in this video, we will be solving the fifth semester and semester examination paper. In this video, we will cover the first two questions and the next questions in the next part of the video. So the first question is, the A part is, take a real world problem and explain how each CRISP TM phase would be applied to address this problem. Include at least one specific task under each phase. And the B part of the first question is, differentiate between unstructured quantitative and categorical data with suitable real world examples. So there are 6 phases of the CRISP PM. So the first phase is business understanding. In this phase focuses on defining the project objective and requirements from a business perspective. The objective is to reduce customer churn by identifying high risk customers so the company can interview with targeted offers or retention. Its specific task includes define the specific key performance indicator, that is KPI, for success. Example, achieve a minimum 15% reduction in churn rate within the next quarter. Then the second phase is data understanding. So in this phase involves initial data collection and familiarization with the data, identifying data quality problems and discovering initial insights. The data is a customer demographic uses pattern. Then its specific task includes access the quality and completeness of the churn variable in the historical dataset, also check missing values and inconsistencies. Then the third phase is data preparation. So this phase covers all activities to construct the final dataset from the initial raw data. Then its specific task includes feature engineering, which calculate the average monthly usage and customer lifetime value, that is CVL, from the raw transaction data to create new predictive features. Then the fifth phase is modeling. In this phase, various modeling techniques are selected and applied, and their parameters are calibrated to optimize results. In this, the specific task includes model building, that is train and optimize multiple classification models using the prepared training dataset. Then the fifth phase includes evaluation. In this phase critically accesses the model build and reviews the step executed to ensure the business objectives are met. Then this specific task is model performance evaluation. Calculate and compare matrices like precision, recall, FN score, and AUC. Then the sixth phase is, and the last phase is deployment. So this is the knowledge or model gained and organized or presented in a way that the customer can use. For a churn predicted model, this means integrating it into the company's operational system. Its specific task includes implementation, that is to integrate the final selected model into the customer relationship management system to automatically score every active customer daily, providing a churn risk score for immediate action by the sales or retention. Now, moving on to the B part of the first question. So, in this, there are 3 types of data types. The first is quantitative data. So, this is data representing measurable quantities or amounts where mathematical operations are meaningful. Its key characteristics include numeric, measurable, and can be continuous or discrete. Then the real world examples are customer spending monthly revenue. Then the usage is call minutes used, and the demographics is age 35 years. Then the second data type is categorical data, that is data representing groups, labels, or characteristics used to classify observation. In this, key characteristics are qualitative, limited number of distinct values, can be nominal or ordinal. The real world examples include in nominal contract type, that is month to month, 2 years, and the ordinal is customer satisfaction rating, that is poor, fair, good. And the identifiers are zip code, that is 90210. Then the third type of data type is unstructured data. So in this, data that lacks a predefined format, organization, or model, making it difficult to process it without advanced techniques. Its key characteristics include qualitative, non-numeric, highly variable and complex, no defined schema. Then the real world examples include text, that is the free from content of an email or a social media comment, in which and the media is a video recording of a meeting or an audio file of a customer service call. Moving on to the next question. So the question 2 part A is demonstrate an algorithm that uses Bayes theorem that solves a small example where prior probabilities and likelihoods are given. And in question 2b, compare the binomial, normal, and Persian distribution in the terms of their assumption and application. So the Bayes formula is given here, where P of A by B is posterior probability, then B by A is likelihood, and the P of A is prior probability, and the P of B is evidence. Now here the real world example, that is email spam detection. So given data is prior probability of spam email, that is P of spam is given 0.2, that is 20% of emails are spam. Then prior probability of legitimate email, that is HAM, is given as 0.80. Then likelihood of word free in spam is P of free by spam, that is 0.8. Then the likelihood of the word free in ham is 0.05. Now the question is, an email contains the word free, then what is the probability of its spam? So we will solve with this step by step. So the first step is calculate total probability of observing free, that is law of total probability. So P free goes like P of free by spam into P of spam plus P of free by ham into P of ham. So the answer comes out to be 0.20. Then the second step is apply Bayes theorem. So when we apply the Bayes theorem in this, we get the answer at 0.80. Then the result is, given the presence of free, there is an 80% probability this email is spam. Then Bayesian classification algorithm goes like a naive Bayes classifier where input is email document with words W1, W2 till WN. The output is classification spam or ham. Then we will first initialize with prior snap that counts spam emails upon total emails, then prior ham that counts ham emails upon total emails. Then the second is, for each word in email, likelihood spam goes like P of word by spam and likelihood ham like P of word by ham. Then the extended example with multiple words is email where free money now is written. So we will draw a flow, this diagram table in which the word is free, money, or now. So the probability of word by spam is 0.8 for free, 0.75 for money, and 0.60 for now. Then the probability of P of word by ham is 0.05 for free, and for money 0.03, and for now we have 0.02. So we will put all these values in the formula, and in the probability of spam by words and the probability of ham by words. So the posterior probability will be significantly higher, correctly classifying this as spam. Now the B part of the second question is distribution comparison. That is, first is binomial distribution. So here models number of successes in fixed number of independent trials. Mathematical formula is P of x is equals to k, where p to the power k and k is minus 1 p to the power n minus k, where n is total number of trials, k is number of successes, and p is the probability of success. So assumptions are fixed number of trials, each trial is independent, two possible outcomes per trial, and possibility of success p is constant, where parameters are n and p. Then we will calculate the mean and variance. Then the real world applications are quality control, marketing, healthcare, and sports. The example calculation. So we will put all these values in the formula discussed before. So the value comes out to be approximately equal to 0.0574. Then we will discuss normal distribution. So the normal distribution is continuous distribution bell-shaped, symmetric around mean. The mathematical formula is given here. You can see this formula. So here the assumptions are data is continuous, distribution is symmetric around mean, then mean is equals to median equals to mode, and the 87, 95, 99.7 rule applies. 68% within 1 sigma, then 95% within 2 sigma, and 99.7% within 3 sigma. Influenced by many independent factors, where parameters are new, that is mean, and sigma, that is standard deviation. The real world applications include human characteristics, finance, manufacturing, education, neural phenomena. The examples are height of a adult male typically between 175 centimeter or 8 centimeter. Then what percentage are between 167 till 183 centimeter. So this range represents plus minus 1 sigma around mean, and the answer comes out to be approximately equal to 68% of males fall in this height range. Now the third is Poisson distribution. So in this, the model count of event occurring in fixed time or space interval. So the mathematical formula is given by this, where t is where lambda is average number of events in interval and k is number of events. Assumptions are events are independent, average rate is constant, two events cannot occur at exactly the same instant, event occurs at random throughout interval, and time interval or space regions are fixed. Where parameter is lambda, that is event rate, and mean, that is nu, then variance, that is sigma square. So the key properties are mean equal variance. This was all about question 2. Now we will discuss the Poisson distribution, this real world application. So the real world applications are customer service, that is number of calls received per hour, then traffic, epidemiology, web traffic, and defects. Example calculation is website receives an average 10 visitors per minute, probability of exactly 8 visitors per next minute. So we will put the values in this formula, then the value come out to be approximately equal to 0.1126. Now the comprehensive comparison table for normal distribution. So this we have already discussed in the previous slide. Yeah, so example calculation is website receives average 10 visitors per minute. So this is the value. Now the comparison table is this, where criteria we have taken as type. So the binomial is discrete, normal is continuous, and Poisson is discrete. Then the parameters used in binomial are n and p, and normal we have nu and sigma, and in Poisson we have lambda. Then mean is calculated by np. In normal we have nu, and in Poisson we have lambda. Then variance is calculated by np, 1 minus p in binomial. Then in normal we have sigma square, that is variance, and in Poisson we have lambda. The shape of binomial depends on n and p, and in normal it is bell curve, and in Poisson that is right skewed. Then for trials or events, in binomial we have fixed and normal we have continuous, and in Poisson we have random count. Then the use case, in binomial we have pass or fail outcomes, in normal we have measurements, in Poisson we have event frequency. Then for example, in binomial we have coin flip, in normal we have heights, and in Poisson we have arrivals. The approximation is binomial we have normal if NP is greater than 5. In binomial, in normal we do not have any approximation, and in Poisson we have normal if lambda is greater than 10. So it was all about question 2. We'll discuss the next question in the next part of the video. Thank you.